Welcome everyone. Welcome to OdinSchool of Technology. Now, in this class, we are going to learn about a very important technology called MySQL. This MySQL is basically a product of Oracle, which is simply nothing but an extended version of SQL powered by Oracle in the backend. Now, first let's understand what is SQL, why do we need SQL in an IT environment, what is the role of a database, what is the role of a server, and every other thing in this particular class. Before getting into the class, let me quickly ask the most important question. Why learn MySQL? The most important answer to this is without a database, none of the organizations would be able to efficiently handle the large amount of data that they have currently. Now, I'm very sure everyone knows that every organization has huge amount of data, be it from the client side, be it from the stakeholder side, be it from the same company itself. Now, whenever you have huge amount of data, we always follow a process of storing the data. We always use our hard disk, we use pen drives to store small amount of data. Whereas in companies where the data is in terabytes and in petabytes, the huge volumes of data, they can be stored in hard disks and pen drives. We need special environments and special hardwares through which we can store the data. That is the concept of database. Learning MySQL is going to be a solution for almost in all the organizations wherever you are going to work as an analyst or a data scientist or any other role relevant to accessing data. You must know a database concept. MySQL is one of the primarily used database service compared to other services that are there. To just give an example, the other services that we have in the markets are SQL Server from Microsoft. We have Oracle products, PL SQL as well. But however, MySQL stands alone and is one of the market leader in terms of service offered to database. That is why you need to learn MySQL without any doubt. Now, before getting into the technical content, let me quickly introduce about the OdinSchool as well as myself. OdinSchool is a technology upskilling platform. They help us continuously acquire new skills. So their motto is to stay skilled and staying ahead in the market. So it is very important that we need to put your time into a platform where they spend time in upskilling your technological skills and making you stay updated in the current market environment. Talking about me, my name is Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist. I work in a bank. I also have worked with several domains, including retail and recruitment. The technologies that I use in a day-to-day basis starts with Excel, SQL, Python, Tableau, machine learning, and Alteryx. That's pretty much is about me. Now, first, let me give you an overview of today's agenda. Today's agenda is going to be learning about key things, getting started with MySQL. First few things are servers, databases, and tables. And we are also going to learn about what is a select and a from statement, and most importantly, what are constraints. All these three are very important to get started with understanding the database structure. So we will primarily focus on helping you understand how a database works, what are the components of database, what is a database made of at a higher level and a lower level as well. With that said, let's get into the main question. What is SQL? SQL stands for Structured Querying Language. It is basically a scripting language. Do not confuse yourself this with a programming language. A programming language and a scripting language completely different from each other. Even though in both the cases we will be using syntaxes that are already predefined, we generate or use SQL and different programming language for different purposes. Here, this scripting language can help us do only one task, which is ETL, extract, transform, and load data into some other environment. So E stands for extract. When I say extract, it is basically, as I told you, huge amount of data is there in every organization. I will not be requiring the entire set of data for me to perform a certain task and generate an output out of it. So I have to select only the required data for me and extract it from the tables that we have. We will have thousands of tables. So I'll pick the table that I wanted the value to come from, and I'll extract only the number of rows that I wanted to extract it from. So extracting data from the huge amount of data is the first step in a database. The second thing is transforming the data. There is a concept: raw data is always a messy data, which means that the data that is collected by the business, basically, to give an example, if you go to a supermarket, the data gets collected, the billing data gets collected in a spreadsheet type of thing, basically like an Excel. So the users, the customers who are giving purchasing something are going to tell the users that they have bought this many items, and these are the quantities of price to it. Now what they do is they enter the value in it, and then they store it and then generate a bill to you, as well as they will retain a copy for themselves. Now this raw data collection method is not a streamlined method. Everyone can store their data in their own way. I can store the data that I collect in an Excel file. Someone can store the data in a TXT file. Someone else can store it in a CSV file, and so on. So the data collection method is not universal. Everyone have their own way of collecting data. Hence, the raw data in the business is always complicated. To give one more example to this, someone might say under the column country, someone might write India, someone might write only IN. Okay, there is the value, the context is same, but the values are different. A machine cannot understand context. The machine can understand only values. So the next big thing that we will be doing after extracting data is transforming it. Without transforming the data, we will not be able to you know understand how the data can be very streamlined, how the data with one source of dimension can look like. If I'm combining data from 10 different branches of a company, and then I'm transforming the data, and then keeping it as one final table, all the values should follow the same pattern. If I'm using the full form of my country, and which is India, under the dimension country, I have to keep India only throughout my entire data set. I cannot keep IN, or I cannot use any other form of it. So it is very important that we transform the data into required things, not just data cleaning. We will also do aggregation data processing. When I say aggregation level data processing, it is basically we have data at a granular level. Every customer's information that we have: Gautam purchased so much, Varun purchased so much, Anita purchased so much. We have information of each and every customer at a granular level. But when we are trying to consume the output or try to understand the pattern of the business, we will not be able to go through each and every customer. So what we will do is we will group the values of customers. So I will say the sum of sales that happened during the first half of the day is this much, rather than telling the business owner that these many customers came, this customer bought this much, customer B bought this much, customer C bought this much, which might be confusing. But if we can group the values, which is basically aggregation, if we can group the values and convey the output to the business user, they will be able to understand the output and try to understand the business. It is all about helping business through the help of data. The raw data cannot give you business information, so we will transform the data into a way which can give information directly to business. This is what transformation does. Talking about the last piece of database, which is loading the data into another environment. Now SQL is solely a data retrieval and a data analysis platform. I cannot do data visualization in SQL. If I wanted to build a dashboard out of the data that I have, I cannot do it inside SQL, because SQL is not a data visualization tool. It is just a data retrieval, data storing and data analysis tool. I can store the data in it. I can retrieve the data whenever I wanted to have. I can do whatever analysis that I wanted to do, but I cannot visualize the outcome. So we will be loading the processed data. When I say processed data, which is basically the transformed data, the aggregated data. We will put this data into another environment. So what we will do is we will directly load the data from the SQL environment into some other technology like Tableau, Power BI, ClickView, ClickSense, all those things. So that is the concept of ETL. ETL is the most important objective of any SQL. Now, talking about theoretical understanding of SQL, it includes database creation, deletion, fetching rows, and modifying rows. Basically, lets you modify data and manipulate data, right? Then it helps in manipulating and retrieving data stored in a relational database like MySQL, MS Access, Oracle SQL, Sybase, Informix, PostgreSQL, SQL Server, as these servers use SQL as standard database language. So basically, SQL is a language. We need this language to be implemented, written in some environment, and generate an output out of it. It is important that we generate an output by processing the raw data. So what we will do is we can take the help of several companies which provide you an environment to write these SQL queries. So if I'm taking MySQL, the concepts through which we retrieve the data remain the same, but the environment differs. Basically, the tool in which we are going to execute the piece of code differs. We can use MySQL, we can use MS Access, we can use Oracle, we can use Sybase, we can use Informix. Everywhere these are tools, but the syntaxes are going to be the same. Since it's a scripting language, we are going to use a lot of you know what is this syntaxes already predefined to achieve an output. All these syntaxes will remain very same in almost all these technologies, all these softwares, just that the environment differs. This is the concept that we are learning in this particular deck. Let's move on to the next one. I was talking about server, databases, and tables. Now, servers, that is the first thing that we need to understand. Servers are basically nothing but collection of databases. Now, I have two databases here. Sales database I have, and then I have production database also. So, a database is simply nothing but collection of tables. See here, in the sales database, I have customers table, I have staffs table, I have orders table, I have stores table, I have order items table. In the previous slide, there was a terminology saying that relational databases. So there are different types of databases, but we are going to focus on relational database. Relational databases are simply nothing but databases in which all the tables can be interconnected with each other, keeping only relevant information, relevant tables under a database. Under the sales database, I have information only relevant to tables. I cannot have college information in the sales database. College and the sales do not have any correlation between them. So relational databases are databases that can be that can be used to interlink everything that is inside them. So inside the database, there is simply nothing but tables. What a table is made up of? A table is simply nothing but the structure of a matrix. A matrix is simply nothing but rows into columns. So basically, you will have tables, which is basically rows into columns, and then these tables combine together to form a database, and all the databases combine together form a server. So server is basically the combination of both databases and tables. So server is kind of a hard disk. You can remember it server as a hard disk where all the databases are stored and monitored and maintained. So if there is any technical issue that is happening in the database, all those issues can be sorted via server. So only in server, which is a cloud environment, we will be storing the huge amount of data. We, as in the companies, will store the huge amount of data. Then all these databases can be accessed with security. Now, say for an example, I am going to work on a project regarding sales information. This particular sales information project does not require me to know what is there in the production database. So I will not be given the privilege to access the tables or view the tables that are there inside production database. Rather, I will be given permission only to work on sales database, where I will be able to access only these 5 tables. customers, staffs, orders, stores, and order items. Right? This is the concept of server, database, and table. Let me show you this in a real time. Now, what I'm going to do is I'm going to use a MySQL Server Management Studio for executing all the scripts in this particular class. Let me show you how a server will look, how a database gets structured inside those servers, and how tables are part of those databases. Now, what we are seeing here is at the top, if you see here, it says SQL Server 12.0.2269. So this is basically a server, basically an environment where I can store all my databases. See here, it gives me databases. It gives me an option to add security information, security. It gives me server objects, replication, and management. But our focus is on databases. A database is simply nothing but filled with tables. These are the four databases that are available currently: master, model, MSDB, and tempdb. Now if I see master database, I have tables, views, synonyms, and other services. Our focus is only on tables. If I open system tables, these many tables are there under the database master for me to access, retrieve data from, and play with it. Let me show you one more database. Say for an example, I'll choose model. Under model, we have tables. Under system tables, there are no tables, so I'm going to ignore this database. Let me move on to the next database and check if there are any tables in there. In MSDB also, in MSDB we do have a lot of tables, but these are system tables, so I don't want to manipulate anything in it, so I'll directly go into tempdb. Here I might have a couple of tables for our use case scenario, but there are no tables in this case as well. So we are going to use blood pressure, our customers table, which is an external table in our case, to access data and play with it. Now using new query option, I'm going to use new query and write the SQL syntax through which we can retrieve data. Now if I wanted to retrieve the values that are there in a particular table, all I have to do is I have to write a particular piece of code, which is a select statement and a from statement. We will learn about select statement and from statement and come back to this environment. Select statement. As I've told you, select statement is basically nothing but a data retrieval statement. Now I have tables. What is a table? A table is simply nothing but collection of rows and columns. Now if I ask the machine to retrieve me data from the entire table, it retrieves me all the columns and all the rows. But remember that I said we will not be requiring all the columns and all the rows in all the cases. So if I wanted to pick a particular column from the table and retrieve the output out of it, I can use it. Also, select statement works as a print statement for us. Print statement is simply nothing but trying to generate an output in the defined way. That is what a select statement does. Theoretically, select statement is used to fetch the data from a database table that returns the data in a form of result in table. These result tables are called as result sets. These are technical understanding, just book information. The statement also works as a print statement, enabling us to customize the output. It will allow arithmetic, logical, and aggregational operations to perform on the selected columns. Let me go to the environment. See here, what I'm going to do is I'm going to use select statement and then retrieve data from a particular table. Before retrieving table, let me show you how a select statement will work. I will say this is for testing purpose. Okay, so what this does is if I execute this will generate an output which is exactly what I have given here. It will say this is for testing purpose. See here, it prints me the output exactly like how I have given in this particular syntax. Now I will ask the machine to perform an addition 10 plus 15 or 10 plus 12. So what happens in this particular case is that it generates an output which is 22 by performing an operation here. Here we have used an expression and asked the machine to perform an operation. Here we just use a string and ask the machine to generate the output out of it. So basically select statement generally works as a print statement. It focuses primarily on generating output from a given selection. That is what a select statement does. Now talking about the data retrieval from the table using select statement, let me give an example. See here we have several tables, but these are system tables, so we will not understand the data in it. These are customer tables. One is a customer information table, another one is blood pressure table. See, if I wanted to see what I'll do if I wanted to retrieve data from the complete table. I've said select everything. If I use asterisk, it means everything. Select everything from the table. What is the table? The table is customers. As soon as I start typing, it gives me the option to choose customers. As soon as I choose this, all I have to do is just execute this. So what it will do is it will give you the values that are there in the entire table. It has customer ID, customer name, city, grade, and salesman. So basically select statement decides what needs to be shown in the output. That is what a select statement does. Assume I wanted to retrieve only customer name, city, and grade. I don't want customer ID or salesman ID. How do I achieve it? It's very simple. As I told you, select statement works as the selection criteria. In this select statement, I will write cust underscore name, which is the column name. I'll give comma, then I will write city, then I'll write comma, then I will say grade. I wanted all this to be retrieved from a particular table, which is customers in our case. So I have selected this query, executed it. See here, it prints me only customer name, city, and grade. But look at the column names. These column names are not user friendly. These column names does not give us the complete information, or it does not gives and complete information for someone who does not know what is cust underscore name. So what we can do is we can also take the help of select statement to format the output. How will I do it? Using an alias. See here. So what I'll write is select cust underscore name, but I wanted this particular dimension to be written as customer name. Okay, so what I am using here is I'm using an alias which creates a temporary renaming for the columns. The column name inside the table, inside this raw table, remains the same. There is no change to the table column name in the table, but in the output that we are seeing gets converted to customer name. Let me show you the output. I wanted the city as customer city, and I wanted to write grade as customers grade. Okay, I wanted all these operations to be performed on customers table. So what I'll do here is I'll just choose everything and then execute this piece of code. See here, the column names got changed: customer name, customer city, and customers grade. So basically what a select statement does is select statement can work as a print statement without retrieving any data. It can just print values as it is. I'll just redo it one more time. Select, this is a print statement. Okay, it can work as a print statement. It can retrieve data from a particular table. It can retrieve all the data from the table. It can retrieve only particular columns from the table, and it can also format the output of the column names as well. Also it can perform aggregation, arithmetic and logical operations for us. So in this case I'll just ask the machine to perform the simplest arithmetic operation. So 10 plus 15 is 25. This is what a select statement does. Okay. Next is the from statement. From clause is used to access the tables in the respective databases. It is the first statement that will get executed amongst all other statements. Yes, it is a very important statement. We have used from statement here directly, but what happens with from statement is that it gets executed in the first place. If you see here, there are four databases: master, model, msdb, and tempdb. I did not specify to the machine that I wanted to access the table from the master database. Directly I gave select everything from customers. It accessed the values that is there in this particular database. Say what suppose if I wanted to access data from a table which is not there in the model master database. Assume it is there in backup file. So what I'll do here is, see here, I'll just show you how does it work. So I'll simply write select everything from the backup file dbo.backup file. Basically dbo is database object, so I can directly say backup file also. Now see what happens when I execute this output. It throws an error. It says invalid object name backup file, but we can very clearly see that there is a file called backup file. But the problem here is it is present in a different database, msdb. So what happens with from statement is that it will always look out for the default database. If you see here, the default database is master. I can change this default database into the database that I wanted to work with. I can choose MSDB. Then what I'll do is I'll simply execute this file and it generates an output for me. So it basically from statement always tries to see if a particular table is present in the active database. If this particular table is not present in the active database, then it will terminate all the other operations that we ask the machine to do and will say this particular object is not present. Now manually, how will I change the database name? All I have to do is I can use function through which I can modify the database. See here, the current database is MSDB, but by using the use function, what happens is it executes the command. It says command completed successfully, and without us manually changing MSDB to master here, it automatically got changed to master. So you can use function also if you wanted to change the database if and when required. So from statements are very important. From statements can do only one thing. It can actually retrieve data from tables. That is all it can do. It cannot do any other operation. From statement cannot take any other arguments. It can take only the table name. It can perform join, but we will see joins later. Okay. This is what a from statement does. These two statements are very important in terms of getting started with SQL. We will also be learning about several DDL and DDL, DML and DCL concepts, which are basically concepts used to manipulate data, define data, control data. We will see that in a little while. Let's first focus on constraints. Constraints. So as the name suggests, constraints are simply nothing but concepts through which what happens is through which we can actually control the tables that we create inside the environment. Suppose we are creating some tables in the a SQL environment. Rather than manually importing the data, if you wanted to create some tables inside databases, you can control what that particular table can contain. You can specify a particular dimension and say that particular dimension should not have duplicate values in it. You can specify a column and then say that this particular column should have values only greater than a particular value. So basically constraints are rules or patterns that we enforce on the columns of the table. So whenever we are creating a table, we can define what that particular table can have or cannot have. That is what constraints are. There are several constraints. We are going to see every one of them one by one. These are used to limit the type of data that can go into a table. So basically it basically controls the data whenever we wanted to control the values inside the table. This ensures the accuracy and reliability of data in the database. That is the pro in using SQL constraints. Cool. Let's see one by one. Not null. So not null is basically a concept which will not allow null values inside the column that we are trying to create. Say for an example, I'm creating a table customers. See here, I'm creating a table customers, and then I can use the same thing to show you an example in the database. So what happens is when I'm using a not null constraint, this particular constraint will not allow any value in that particular column to be left. So we are creating a table. We will create columns first and then we will add values to it. So when we are adding values to this particular column, if you are going to keep it as null, the machine will throw error saying that this column will not allow nulls in it. That is what a null not null function does, not null constraint does. Let's try it out here. See here, let me just quickly format this. So I'll explain each and every piece of code here, so don't have to worry about that. In the interest of time, I'm just copy pasting it directly from there. So here what we are doing is we are creating a table called customers. Okay, this customers is the name of the table. We already have a name of customer, so what I'll do is I'll say salesperson. Okay, salesperson is the table that we are going to create, and I'm going to have different columns into it. The first column is going to be id, salesman id. The second column is going to be the name of the salesperson. Third column will be age. Fourth column will be address, and the fifth column will be salary. So what happens in this case is it creates 5 different columns for us. And if you see here, there are 2 things that we must declare whenever we are creating a column inside the table. We should always declare what is the data type that that particular column can possess. When I say data types, these are basically data types of data that we can actually allow inside a particular column. Now the common data types are integer. Integers are basically nothing but whole numbers, and we have floating data types. Floating data types are basically numbers with decimal places in it. We have variable characters. We have date, we have percentage, and some so many other data types that are present in SQL. But generally what I'm doing here is I'm asking the machine to create a column called id, which will allow only integer values in it. And the important aspect of id, column id, is it will not allow nulls in it. Then I'm creating another column called name, which will have variable character. Varchar is basically variable character. This is the size. If I'm saying 20, it means that 20 characters can be there in this particular column name. So if the name of the salesperson is going to be greater than 20 characters, it will not allow. It will chop off at the 20th character. In this case, if we take an example, Nick Rimando is present. Nick Rimando doesn't seem to have more than 20 characters, so is allowed. Say example, Nick Rimando's full name is Nick Rimando Gaupas. So what happens is then it becomes a name with more than 20 characters. Hence, this particular table column will not allow more than 20 characters. Also, it will not allow null values present in it. The third column that I'm creating is an age column, which will allow only integer values, and again this should not be null in it. Finally, I'm creating address will have characters. It can have both numerics as well as text in it, and it can have 25 characters in it. Salary is a decimal data type wherein you can specify 56,000 or 5.6, 10.9, all those things we can do. So here this is basically the decimal integer count, and this is the decimal count. So it can have up to 2 decimals in this data type, in this particular column. Now let me execute this. It gets executed. It says query executed successfully, but I cannot find the table in this database. So all we have to do is simply refresh the server. Once we refresh the server, the database gets automatically, the table that we have created just gets automatically pulled into the database. I'm just checking. Let me refresh this one more time. Let me check now. See here, the salesperson database is now available in the environment. Now what I'll do is here, select everything from salesperson that we just created. So it will print us only the column names. There are no values in it. ID, name, age, address, and salary. So this is how you can define the constraints whenever we are creating the tables itself, so that the user will not be able to have the option to give random values inside the tables. We can control the values inside them. This is what a not null function does. Constraint. The next constraint that we are going to learn about is unique constraint. So unique constraint is basically, as the name suggests, it can allow only unique values in it. It cannot allow duplicate values in it. Let me show you with an example. Okay, so the theoretical understanding is that ensures that all values in a column are different. I think it keeps moving. The unique constraint prevents two records from having identical values in a column. It is the same thing that I just said. So you cannot have two values which are basically of same thing, basically duplicates. You cannot have duplicates inside a particular column. Now let me create another table now. The other table that I'm planning to create now is, since we already have salesperson table, I will create another table now. I will say, for an example, I will say employee table. So in this case, the first column is ID and it says integer, and the second column is name. It says variable character, and it has the next thing is age, which is an integer, and we also have address, we also have salary. So these are the 5 different columns that we are going to create. And see here, what I have done here is the age should not have nulls in it. Also, it should not have duplicate values in it. If you are going to assign values to the table, to these tables, you should not have duplicate values in this particular column age. This is what a unique constraint does. Again, the process remains the same. You can execute it, and then you can refresh the data server so that the tables get automatically pushed into it. Yeah, it's done now. See here, the employee table is present here. I will say select everything from employee, employee. What happened? Employee, and then just execute this. It prints me all the 5 columns that we just created, and the age will not allow duplicates in that. What a unique does. Talking about primary key. So the concept of primary key and foreign key is very important in terms of database, because only through primary keys and foreign keys we will be able to join or work with several tables at a time. So as I told you, in real time we will be having a lot of tables under a lot of databases. Now if I wanted to perform an operation which requires value from several tables, 5 tables or 6 tables. Now, how do I retrieve the values from each table and convert everything as one single table? Because I cannot have 5 different tables for performing one task. So how do I merge them, and basis what parameters do we merge them, join them basically? Now, primary key is a concept where it basically is a column in the table only. What it will do is it will have only unique values in it. Okay, it will not have any duplicate values, and also it will not have any null values in it. That is very important. Having multiple primary keys are amazing. If you have multiple primary keys in a data in a table, it is really good, but having one primary key is a mandate. Say for an example, the same example, we have so many columns created in the previous case, but we can create only one column to be the primary key for that particular table. So what happens is, this particular column ID in this case that we are trying to create becomes the source of connection for other tables. If I wanted to join this particular table customers, I'll show you that as well. Maybe I'll create another table now, employee, and then I'll say students. Okay, this is the table that I'm creating, and then I'm just executing it. Incorrect syntax near the keyword primary key. So basically it does not allow me to create primary key via this. All I have to do is I can write primary key here. Yeah, I don't want to have it here. I can just keep it there and then close the parenthesis, execute it. It again says an incorrect syntax there. So basically the concept is very simple. It lets me create values that are unique and not have nulls, so that it can be used to map other tables that we wanted to retrieve data from. That is what the role of a primary key is. Just checking what is the issue here. I think there is no issue. Let me execute this. Yes, it got executed successfully. Let me refresh this one more time. Yeah, I've refreshed this enough. Let's see students here. I've created a table called students. Now there are two tables that I wanted to join, right? So what I'll do is select everything from employee table. Okay, join the values to the students table. We will talk about joins in a separate class, but I'm just trying to explain you what does a primary key does. Okay, so what we have to do is we have to specify what is the column through which we can actually create this relationship. So what I'll do is on a dot id is equal to b dot id. So what happens in this case is it creates a it merges the values that are there in these two tables, but the common column that is used to perform this merging operation between these two tables are the primary keys. id is the primary key there. It says, it looks like it throws some error. Students, let's execute this and see what is it. No, there is no error. It directly gives me the value. See here, it gives me the values that are there from the first table as well as values that are from the second table. Just to distinguish what values coming from what table, what we can do is we can use select statement. So I'll write a dot id as a hyphen id. Then I can say a hyphen I just want name from the first table, so I'll write a dot name as a hyphen name. Okay, this is from employee table A. Then what I'll do is I'll join it from B. So from the second table I want the age and the salary, so what I'll do is b dot age as b age comma I wanted the salary as well, so I'll write b dot salary as b hyphen salary. Then yeah, this is all I wanted to have. So I will have four columns now. Column ID from table A, which is basically employee, and column name from employee table. But we'll have age column from students table, and salary column from students table. Now all this operation can be performed only when we have a primary key. A primary key acts as the bridge between two tables in order to map. The same column ID which is present in the second table becomes my foreign key. So if it is present in my first table, then it becomes my primary key, but it becomes a foreign key when I use the same column from a different table to join with. This is the difference between primary key and the foreign key. Could not find a stored procedure ID. Looks like I've made some issue here. Join students b dot id employee. Okay, let's see the values from each table. So select everything from employee, execute it. It has id, name, age, address and salary. So I've used id, name. Okay, there's this problem. It is capital name. I think that is not a problem, but yeah, let me just change this again. It is not case sensitive, but I'm just trying to fix the issue. A.id is equal to B.id. Yeah, see here, it gets executed and it gives me the value. Column ID from A table, column name from A table, column age from B table, and column salary from B table. This is what primary key does. I'm going to use the same example for foreign key once we come there. A foreign key is a key used to link two tables together. This is sometimes called the referencing key. Since we are going to use that uh, column for connecting to the first table, then it becomes a reference column. A foreign key is a column whose value match a primary key in a different table. That is exactly what I was telling before. So exactly the column ID, which is the primary key of column of table A employee, the column ID from the table B, which is students, here it becomes the prime foreign key. Whereas the key that I use in the first place should not have nulls. Here I can have nulls. That is the only difference between primary key and a foreign key. Check. Okay, check is another type of constraint that we can use in order to check or evaluate for a particular condition. Say for an example, I wanted to create a table and I wanted to make sure that a particular value only is allowed in a particular column. Then I can use check constraint to evaluate it and control the data level. The check constraint enables a condition to check the value being entered into a record. If the condition evaluates to false, the record violates the constraint and will not be entered into the table. Basically, it will not allow you to create values that are not fulfilling the condition. Now, the example for this is creating a table which will have several columns and there are conditions to it. Now see here, create table, new table, ID. Okay, ID is a column which is an integer, not null. Name is variable character with 20 characters in it, not null. Age should be an integer, but I should make sure that the value that it is that we are going to supply into this particular column age should be greater than or equal to 18. It should not be less than 18. If it is less than 18, then what the machine does is it simply throws an error and says no, this particular value cannot be used into the particular table. Then I'm creating an address which is a character. Then we are having a column called salary which has decimal data types with the precision of 18 and into decimal value of 2, which is the primary key in this particular case is ID. So primary key can be supplied directly when we create the column itself. So I'll simply write primary key. All I have to do now is just execute this. It got executed and the table got created. The table name is new table. Now for this example, what I can do is I can show you how the data can get implemented into the table and how the constraints react. Tables, we have new table. Okay, so what I'm going to do is insert into new underscore table. So what we have to do is we have to supply the column names. The first column is ID, column is name, third column is age, the fourth column is address, fifth column is salary. Okay, values. Value should be for ID. I'm saying the ID is 1, the name is Varun, the his age is 25, his address is Bangalore, and his salary is 25,000. So we have created this particular table with a particular condition called that age should not allow values that are less than or equal to 18. Now what we have done is we have given value that is greater than 18 only, basically fulfilling the condition. Now let's see what happens when I execute this particular statement. It says one row got affected, which means that the table now has one row and it has the value of all the things that we have supplied. Let me show you the values now. Select everything from new underscore table. Now let me execute this. So here it has the value of Varun, ID 1, age 25, Bangalore, and address and salary and things. Now I wanted to add one more value to the existing table. So what I'll do is I'll create value should be 2, name should be Ajay, age is 17. This is actually less than the condition. If you remember the conditions here, I asked the machine to check where the age should be greater than or equal to 18, but I am breaking the constraint here. See what happens when we break the constraint. Is from Bangalore, his salary is 15 grand. Now if I execute this, it will throw an error. It says the insert statement conflicted with the check constraint with this particular age. The conflict occurred in the database master and the table this, and in the particular column age. So it tells there's a conflict between the check and the values applied to it. So basically it will not let you create a table without fulfilling the conditions that we predefine while creating the table. This is what a check constraint does. Say for an example, I wanted to keep it as null. Okay, I think I have created this column ID. It should not have null, right? So I'm going to use null for creating a value to it. Again, this will throw an error saying that ID column should not be null. This is what a not null does. See here, it says cannot insert the value null into column ID. Column does not allow nulls, because what did we say while creating the table? We mentioned that the table should not allow null for this particular ID. So these are the different constraints that we can have in order to control the data. The another constraint is unique. Unique is basically, I think we used unique in some place in a table. I just don't remember the table name. So what I'll do is I'll just go ahead with trying with this. In this case, I'll check if I've given ID as unique, and then I already have a value of Varun, and then the ID of Varun is 1. Now I'm going to have one more value of 1 and then say the value for Ajay. So it says violation of primary key constraint because it cannot insert duplicate key in it. It will allow only unique values in it. If I say 2 and if I change the value of Ajay's age to 22, then anything they greater than or equal to 18. If I just execute this, it says it got affected. Now if we see the table, it will have two line items. The first line item is for Arun and the second line item is for Ajay. So this is how we create conditions basis which we can create tables and control the data. This is something very important in terms of working in projects that requires handling of sensitive information. So we will always control the user from changing the information that is already there in the table by having enough constraints in the backend. This is what all the constraints does. That brings us to the end of today's class. Let me quickly recap what we have learned in this particular class. So what we have learned in this class is we have learned about servers, databases and tables. Servers are basically the collection and storage of databases. So they are huge hard disks provided by maintained and purchased by different companies. What they will do is they will give services to other companies to use their servers. So companies pay a lot of money to that particular company to use the hard disks that they have. And then databases. In all the memory hard disks that the company is purchasing, the companies can store the data in the form of databases. What are databases? Databases are basically collection of tables. A table is simply nothing but a collection of rows into columns. Basically, it will have only two-dimensional information, like a spreadsheet, like properly an Excel. That is what a table does. Talking about select and from statements. Select statement retrieves the data from the table. It works as a print statement. It also works for performing any arithmetic or logical operation for us. It can allow you to retrieve the whole data as well as a particular amount of data as well. We can control the data using select statement. And talking about from statement, it identifies the table pertaining to a particular database and retrieves values appropriately. You can have the same table in different databases and you can access them through from statement. Talking about SQL constraints, SQL constraints are basically conditions or logics which we will use in order to control the data that it is being created in as a table. There are several constraints. The first one being not null, wherein that particular constraint will not allow you to have a null value in that particular column. And then we have unique constraint. Unique constraint does not allow you duplicates. We have check constraint where it checks for a particular value and returns true or false. If it is true, it allows you to perform the data adding values to the table. Other which ways it will throw an error. Then we have primary keys and foreign keys. Basically, these are keys that are used to, these are the same columns that we have in the data set only, but these columns help us to join or reference each other when, if and when required. That is what constraints does. Now, thank you so much for joining this class. Please don't forget to like, share, and subscribe for this particular tutorial, for this particular YouTube channel as well. Thank you so much once again for joining this class.